Hello and welcome. This is the video solution for quiz 2, or for practice quiz 2. Which of the following terms best describe salt water? Homogeneous solution, heterogeneous solution, pure compound, pure element, none of the above. So when we think of salt water, obviously there's salt, usually sodium chloride, and water, H2O. So we definitely have a mixture or a solution, so not a pure compound or element. And then they're usually mixed uniformly throughout, so that would make it a homogeneous mixture. We would want to be able to see something with our own eyes, or imagine seeing something with our eyes of maybe two different layers, for us to term something a heterogeneous solution. Number 2, which of the following characteristics of a sample of water at room temperature is or are an intensive property? And we're actually told here that this is a property that does not depend on the mass of the substance or the sample. So an intensive property is a characteristic property that's, sort of a characteristic trait of that particular substance. You can think of an extensive property as just being a property of how much of that substance you actually have present. Okay, so the sample has a density of 0.9981 grams per milliliter. Think of it this way. If you had a milliliter of a liquid or a substance and you knew its density, you could take another milliliter of the substance and know its density should be exactly the same quantity, because that's a characteristic property. So that would be an intensive property. The sample has a temperature of 25 degrees. So if you have say you have a gallon of water, one part of it is 25 degrees, the other part of it is 25 degrees. The temperature of the sample is also a characteristic property. That's an intensive property as well. Then the sample has a volume of 100 milliliters. That volume is certainly dependent on how much volume there is. It's a quantity dependent variable. So that would be an extensive property, not an intensive property. So A and B are the correct answer would be D, both A and B are intensive properties of the substance. Okay, number 3. Which term applies to N2 gas, which is a major component of the atmosphere? Our atmosphere is about 78% by volume nitrogen, 21% oxygen, which takes the form of O2. So oxygen molecules comprise oxygen in the atmosphere. Nitrogen molecules, N2, two nitrogens bonded together, comprise nitrogen in the atmosphere. And so N2 would be a molecule. So the molecule N2, that's a molecule of nitrogen, but it's not a compound. Compound, we need to have two or more elements present, making up the actual compound. So we only have one element, so we can only term N2 as a molecule, not a compound. So only one is appropriate for N2. So if we had something like H2O, H2O would be a molecule and a compound. If we had something like CH3OH, molecule and a compound. Maybe we'll get into this a bit more later. NaCl is actually not a molecule, but it is a compound. Our ionic substances, our plus minuses, exist as lattices, where we have a network of ions that are all intermolecularly attracted, or that are all attracted to each other by ion attractive forces by electrostatics, make up things like NaCl. So NaCl would be best described as being a compound, not necessarily a molecule, but perhaps we'll talk about that more later. Okay, now getting to number 4, which purification method would be best to separate water and methanol? And we're given the choices here of chromatography, distillation, filtration, chemical reaction. Okay, so these are discussed a little bit within chapter 1. Chromatography would be, how you might separate inks within, say, a black ink pen. If you have black ink, you have ever had maybe like water travel through the ink blot, you can usually see the separation of the blue and the purple colors that comprise that ink. So the ink itself isn't the black color, but it's just the appearance of the colors that are mixed within within that ink. And so then maybe you can think of paper as acting as a solid support that can separate the two different liquids, the different liquids within the dyes, because those dyes travel through the paper with a different rate. So that's chromatography. Chromatography doesn't really work well to separate, or maybe it's not best to separate water and methanol. So let's think of something different. Distillation is a great technique to separate substances that differ in boiling point. So if we have a low boiling point substance, then we can think of heating up the mixture. Predominantly, the vapors of the liquid will be more concentrated in the lower boiling substance. That's why it boils at a lower temperature. So then you can distill the vapors, purify them or allow them to condense, they're going to be more concentrated in that lower boiling substance, methanol. So that might be our best way to separate. Filtration is a great way to separate a solid from a liquid. So if we had a heterogeneous mixture of a solid and a liquid, if we had some sort of salt that's insoluble in water, we could separate it from the water just by simply filtering. This chemical reaction is mentioned a little bit within this chapter, but this would not really be a good idea for water and methanol because we could easily use distillation to separate them. But chemical reaction would be, react one of them, maybe turn it into a solid that you can then filter. So filtration, maybe this works well if you imagine having something that's water soluble and water insoluble in a solid. All you need to do is add water, and then the water soluble substance will dissolve, and then you can filter that substance away from the other substance, which perhaps is water insoluble. So chemical reaction works well when we need to separate substances maybe that don't have a difference in boiling point, but have maybe some different chemical property trend. So distillation would be the best technique here for water and methanol. And then which process below is a chemical change. That's really meant to be as opposed to a physical change. A physical change is a change in state, melting, or freezing, or boiling, or condensing. And so water boiling is a physical change, not a chemical change. So a chemical change, we're thinking of changing the actual bonds of the atoms within the substance. So if we just boil water, we're taking water where the molecules are really close together, and then boiling them so that they're much further apart. So liquid water molecules have some intermolecular forces of attraction that have to be broken to allow it to boil. So we have to warm the temperature up of a liquid water sample to allow it to boil. That's just simply a physical change. We're not breaking the bonds between water molecules, we're just breaking the attractive forces between two adjacent water molecules through the boiling process. The combustion of methane, we'll see a bit more later that combustion is the act of oxygen reacting with substances like hydrocarbons to make CO2 and water. We can think about balancing reactions, so we need two waters here, and then we will need two oxygen molecules to combust with the one CH4 molecule. This is definitely a chemical change. That's a chemical reaction, so only two here. Methane combustion is an example of a chemical change. And we can all imagine having seen or using methane or natural gas for a heating gas, perhaps in a stove or a furnace. Okay, so that's the solutions for quiz 2. Thanks for the attention.